everyone. My name is Abhishek and I am mathematics faculty here at askIITians. So this is lecture number 2 of this particular chapter, that's mensuration. And as we do in every session, before we delve into the topics that we are going to cover in this particular session, let us revisit the weightage of this particular chapter for both school examination and your Olympiad examination. If I talk about a school examination, then the weightage of this chapter is around 11 marks. So that means roughly you can expect around 3 to 4 questions from this particular chapter. And if I talk about Olympiad examination, in Olympiads, the weightage is around 3 to 4 questions can be expected from this chapter. What makes this chapter more important is that this chapter will be there in your 9th standard. It will be there in your 10th standard. So since you are going to see this chapter in your upcoming classes as well, so it's very important for you guys to understand this chapter thoroughly. Because if you get good command over this particular chapter in this session only, like it will be easy for you guys to handle this chapter in your senior classes. So now let us see which topics are we going to cover. So these are the 3 topics that we are planning to cover in today's session. The first is we are going to discuss what is surface area. Then we will discuss the surface area of cube. We will discuss surface area of cuboid, and we will discuss surface area of cylinder, like what is the formula we have for all 3. We are going to discuss the application of that formula as well. Then we are going to discuss what is the meaning of volume. Then the volume will be discussed for cube, cuboid, and cylinder, all 3. At the end, we will be discussing the relation between the volume and capacity, relation or difference, whatever you want to call it. That is what we are going to discuss in our topic number 3. And in all the cases, we will do some problems based on that so that you can understand the application of the formula as well. All right. So I think we should start our session. So what is the very first topic we have? The very first topic we have is surface area of cube. We are going to discuss cuboid. We are going to discuss cylinder. We are going to discuss. So we need to understand what is the meaning of area, and then we are going to discuss what is the meaning of surface area. All right. So if you talk about area, the space occupied by a 2-dimensional flat surface is called area. That means if you have, let's say this is a 2-dimensional figure you have. Okay, this is any quadrilateral, for example. Clear? I am going to give it a name. That name is ABCD. So the space which is occupied by this figure which I have drawn, I am talking about this space which I have shaded in yellow color. So the space which is occupied by this figure that is denoted or that I have highlighted using yellow color, that is called the area which is occupied by this 2-dimensional figure I have, or this plane that I have. And we discussed this point in our last session as well. Okay. And how is it measured? It is measured in square units. We discussed this as well when we did many problems. All right. On the other hand, the area which is occupied by the outer surface of a 3D object is called surface area, and it is also measured in square unit. All right. So that means if you talk about this very first figure that you are provided here, which is cuboid. Okay. Then this cuboid, if you talk about cuboid is a 3-dimensional figure. As it has got 3 dimensions. One of the dimension is length, the other dimension is breadth, the third dimension that you have is height. Okay. So if you talk about this cuboid, you can see then this cuboid occupies this space, like this face is there. You have second face, you have third face, you have fourth face. One is at the back and one is at the front. So these 6 faces that you have here, these 6 faces are occupying some like these 6 faces that you have, these are 2-dimensional faces and they have some area, isn't it? So when you like this area which is occupied by the surface, you can say, or the faces of this 3-dimensional object, which is cuboid in our situation, is what you call as surface area. And we have surface area of different types. Okay. So if you talk about area, if you talk about total surface area, what is the meaning of total surface area? We need to understand total surface area means we are talking about area of all the six faces. Area of all the six faces. Okay, because a cuboid has got six faces, so when you calculate the area of all the six faces, you add the area of all the six faces. What happens is the result which you get, we call that result as the total surface area of cuboid. And how do we calculate it? It's super easy. You can check out. This value is h, this is b, this is l. So this value is also going to be L, okay, as these are congruent faces, and this value is going to be B. So if you calculate the area of this face, the area will be L into B, because this face is rectangle in nature. If you calculate the area of this face, the area would be L into B again, because it is rectangle in nature. If you calculate the area of this face, it is going to be B into H. If you calculate the area of the face which is opposite to it, that is also going to be B into H. And if you calculate the area of this face that you have here in front of you, that is going to be L into H. The same area will be there of the face which is directly opposite to it. So overall, you have got six faces, and here we have got two congruent, like three pairs of congruent faces, right? And each pair, like one of the pair will have area L into B, the other pair has got area B into H, the third pair has got area H into L, right? So if you add all of them, what do you get? You get twice of LB plus BH plus HL, and that gives you the total surface area. Here, what is this TSA? This TSA is the short form for total surface area. Understood? Total surface area. Clear? Now comes the lateral surface area. Clear? What is the meaning of lateral surface area? You have this cuboid in front of you. If you exclude the area of this top that you have and this bottom that you have, then the area of the four sides which are remaining, let's say you are sitting in a room. So in a room, if you exclude the area of the top and the bottom, then the area of the four walls that you have, we call that the lateral surface area. And the area, lateral surface area basically means area of the faces excluding top and bottom. I'm writing here for your understanding. Okay, area of the faces excluding top and bottom. Top and bottom. All right. So if you exclude the area of top and bottom, you get 2L plus B into H. And because this is very similar to the situation when anybody asks you to find out the area of the four walls of a room, all right, then if you have to calculate the area of four walls of a room, all you have to do is you have to exclude the area of top, you have to exclude the area of bottom, you have to add the area of the four walls that you have in your room, and you get the exact same value. So this LSA also gives you the area of four walls, because you will see many problems related to finding out the area of four walls of a room. So calculating area of four walls of a room or calculating lateral surface area of a cuboid, that is exactly same thing. I hope it is very clear to everyone. So I hope the meaning of total surface area. Total surface area means we are talking about area of all the faces that are there in the given figure. And since in cuboid you have got six faces, so you have to add the area of six faces. When you add the area of six faces, this is the value that you get. When you are talking about lateral surface area means area of all the faces excluding the top and the bottom. So when you calculate area of all the faces excluding top and bottom, you get twice of L plus B into H. And area, lateral surface area and area of four walls is exactly same thing. Don't get confused. All right. So now I think we should move to cube. So if we talk about cube, the only difference that we have between cube and cuboid is that in case of cube, all the sides or all the edges that you have, if I have to say, all the edges, they have the same length. So if this is A, then this value will also be A. The height is also going to be A. So if you calculate the area of this face, let's say, because the face is square in nature in case of cube, the value is going to be A square. Similarly, the area of this face will be A square. The area of this face will be A square. And overall, how many faces do we have in cube? The total number of faces in a cube is same as the total number of faces in a cuboid, that is equal to 6. So that is why you have 6a square. That means area of one face multiplied by 6, because you have 6 face in total, gives you the TSA, which is total surface area. And again, when you are talking about lateral surface area, that means you have to exclude top and bottom. When you exclude top and bottom, you are left with 4 faces. And if you want to find out the area of 4 faces, that is going to be 4a square. That's very, very easy. Understood? After that, what do we have? We have cylinder. All right. So in case of cylinder, what is the meaning of TSA? See, before moving to TSA, we should understand what is the meaning of CSA. Clear? So what is the meaning of CSA? CSA means the area of this curved part that you have here. I'm trying to show that to you. So this curved part, which I am trying to show using green color, you have to find out the area of this portion. The area of this portion denotes curved surface area. And what happens here, or how we got this 2 pi RH? Basically, this part that you have, like what is the height of the cylinder? Height is h, okay? And this cylinder that you have, it is actually made of small circles put together one over another. Clear? This cylinder is made of small circles that we have put together over one another. And what is the circumference of a circle? The circumference of one circle is given by 2 pi r, right? And what is the height? Height is h. That means how many circles are we using to form this cylinder? We are using h circle. So if you have to find out the area of the h circle, sorry, circumference or the length, basically, then that would be given by what? That will be given by 2 pi r into h. This will be what? This will be circumference of one circle. This will be circumference of one circle. And what is that h? That h denotes height of the circle, height of the cylinder, or basically the number of circles that are coming together to form the cylinder. And that is the reason we get 2 pi RH. Is that clear? Apart from this, we have TSA, or total surface area. What is TSA? Let us understand. When I say TSA, T stands for total. Total means everything that you can touch in the cylinder, you have to find out the area of. So when you are talking about TSA, then in TSA, what do we have? You have to find CSA, okay? Plus you need twice 2 into area of circular basis, both the circular ends that you have. Is that clear? Circular ends. And what is CSA? CSA is, what is CSA that we have? CSA is 2 pi r h. And what will be the area of one circular end? The area of one circular end will be pi r square. So the area of two circular end will be 2 pi r square. You can take 2 pi r common. If you take 2 pi r common, inside the bracket, you will be getting h plus r. And that's exactly what we are provided here. So I hope the meaning of surface area, the surface area in case of cube, in case of cuboid, and in case of cylinder, be it total surface area, be it lateral surface area, or curved surface area. See, technically speaking, there is no major difference between lateral surface area and curved surface area. We use this term lateral surface area for figures like this, like figures like cuboid is there, cube is there, right? And we use this term curved surface area for which that portion is curved in nature, right? For example, there is cylinder, there is cone. You will come across many other figures like this, but technically, more or less, they are same thing. I hope it's clear to everyone, because after this, we will be doing few problems based on it. Is it done? All right. So now you can see we have one problem. Let's see what we have to do in this. Daniel is painting the walls and ceiling of a cuboidal hall. Okay. Length is given, width is given, height is given. Let's see what is length. Length is 15 meters. So let me write that value here. So the length of wall is 15 meter. I have denoted length by L. Breadth is given 10 meter. So I have denoted width or breadth by 10 meter. And height is given 7 meter. Okay. We have from each can of paint 100 meters square of area can be painted. They are asking you how many such cans of paint will be needed to paint the room. All right. It's very easy. What does it say? It says that if you have one can of a paint, then using that one can of a paint, you can only paint 100 meters square of the area. And you want to paint this entire wall which is in front of you. So all you have to do is, if you want to find out how many cans will be needed for this task, you find out this total surface area of this wall. Okay, and after calculating the total surface area, what Dale is painting the walls and ceiling. Okay, so you are painting 4 walls and the ceiling, so you have to find out the area of these 4 walls and the ceiling. Then whatever value you are going to get of the area of walls and the ceiling, you divide it by 100 meters square, you will easily get the value. And that's exactly what we are trying to say here. Clear? See, guys. Okay, so let me show you. Let's say this is a room you have. Okay, clear? So we want to paint this part, that part, front part, and that back part. Clear? So if you have to find area of the region to be painted, or the portion to be painted, area of the portion to be painted. So we need to paint area of 4 walls. Okay, area of 4 walls. Okay, plus area of ceiling. That's what we need to paint. Clear? Area of 4 walls, we know the formula, that is twice of L plus B into H. Correct? And if you talk about ceiling, this value is going to act as length and this value is going to act as breadth. So the area of this ceiling is going to be L into B. So you will have plus LB. Let us substitute the value. So you will be getting twice of 15 plus 10 multiplied by 7 plus 15 into 10. Clear? So here what will you get? You will get 2 into 25 into 7 plus 150. 2 into 25 is 50, and 50 when multiplied to 7, that gives you 350. So you have 350 plus 150. That means that total area that you need to paint is 500 meters square. Okay, this much area you need to paint. Now, what other information are we provided here? We are also provided that using one can of paint, you can only paint 100 meters square of the area. Okay, area that can be painted, using one can, that would be 100 meters square. Okay, therefore required number of can will be what? Required number of cans, that will be equal to total area divided by area covered by one can. Okay, so you just put the value, you will get 500 over 100. So what will you get? You will get 5. That means you need 5 cans to paint the 4 walls that you have of the room. And apart from 4 walls, if you are interested in painting the ceiling as well, then yes, 5 cans are needed for sure. I hope it's very clear to everyone. You can go through it. Ask me if you have any query in this. Is it done? All right. So that's exactly what they have done here. Since Daniel has to paint 4 walls and the ceiling, he has to cover 5 portions in total. And the surface area of 4 walls is given by 2 into L plus B into H, or W, whatever you want to call it. And area of ceiling will be L into B. So the total area to be painted will be 2L plus B into H plus L into B. If you simplify it, you get 500 meters square, correct? And by using one can, you can paint around 100 meters square of area. So in order to paint 500 meters square of area, you have to divide this 500 meter square by 100 meter square, and when you divide these two values, you will be getting 5. That gives you the total number of cans that will be needed to paint the area. Clear? All right. So now we are going to discuss about volume of cuboid, and cuboid and cylinder. So we all know what volume is: the amount of space measured in cubic unit that an object or a surface occupies is called volume. Okay. So basically, how much space that an object which is given to you is going to occupy, that space which are given, which any given any given object, I would say, is going to occupy, that amount of space is referred to as the volume of that particular object. And the important point to note here is it is given in cubic unit. Okay, like when we were talking about area is generally given in terms of square units, and if you are talking about volume is given in terms of cubic unit. That should be very, very clear to everyone. So if you talk about cuboid, the volume of cuboid is given by L into B into H, because actually cuboid is a combination of H number of rectangle. Is that clear? Like you have here H number of rectangle which are put together one over another. And if you calculate the area of one rectangle, the area of one rectangle is L into B. And here we are talking about H rectangle, then it is very clear the area of, or the space which will be occupied by the H rectangle, that will be given by H multiplied by L into B. And that's how we get this L into B into H. Okay, I am writing here, that is H rectangle multiplied by area occupied by one rectangle, occupied by one rectangles. Clear? Similarly, if you talk about cube, then in cube, what are we doing? We are actually taking one square. Let's say this is one of the square. Okay, and you are going to put one more square over it, then one more square over it, then one more square over it, then one more square over it. And in this way we have a square. Okay, so here we have total number of a squares which are put together one over another, and we know what is this area of one of the square, that is a square. So since you have in total a squares, the area which will be occupied by one square will be a square. So if you have to find out the space which is occupied by a squares, that will be a multiplied by a square. And that's exactly how we got the formula for the volume of cube. The same concept is there for cylinder also. In cylinder, what are we doing? We are actually putting h number of circles over one another. Clear? What we are doing? We are putting h number of circles over one another. Okay, so these are h circles you have. And if you talk about the area of one circle, the area of one circle is given by pi r square. So if you have to find out the area of the h circles which are put together one over another, then you have to multiply the area of one circle by the total number of circle, which is h in this situation. Therefore, the volume is going to be pi r square multiplied by h, and the formula is pi r square h. And again, I would like to re-emphasize that particular point. Whenever you are calculating volume, it's super important for you guys to write the unit in terms of cube. Okay, like if the values are in terms of centimeter, your answer should be in terms of centimeter cube. If it is in terms of meter, your answer should be in terms of meter cube. That is super important. Clear? Please let me know if you have any doubt in this. Otherwise, we will do one problem based on it, guys. Done? All right. Now they are asking you calculate the amount of air that can be accumulated in a cube of side 3 meter. So accumulated means that can be contained. Okay, that's a dictionary meaning of this. In a cube of side 3 meter. So the length of the edge of this cube is 3 meter, not centimeter. 3 meter. Okay. So basically, what they are asking you indirectly, they are asking you, you have to find out the volume here. Okay. So if you calculate the volume that you have here, what will be the volume? We know that volume of a cube is given by side cube. The length of the side is equal to 3 meters. So you are going to get 3 cube. 3 cube is going to give you 27 meter cube. Like that's answer. Super easy. Clear? And you can see that's exactly what we are provided here. The amount of air that can be accumulated into cube is same as the capacity of cube, which is same as the volume of cube. And volume of cube is given by side cube. So you are going to get 27 meter cube. That's the answer to this. Clear? Now we have a matchbox measures 4 centimeter into 2.5 into 1.5 centimeter. What will be the volume of packet containing 12 such boxes? So if you want to find out volume of packet which is going to contain 12 such boxes, so your required volume will be equal to what? That will be equals to volume of one matchbox multiplied by the total number of matchbox. Okay. So for matchbox here, what are we provided? We are provided L. What's the value of L? L is 4 centimeter. You are provided breadth, which is equal to 2.5 centimeter. And you are provided H, which is equal to 1.5 centimeter. We all know matchbox is actually cuboidal in shape. So if you calculate the volume of one matchbox, what will you get? Volume of one matchbox, that will be equals to what? That will be equal to L into B into H. So you are going to get 4 into 2.5, that is multiplied by 1.5. You can remove this decimal, you will get 10 here. You can remove this decimal, you will get 10 here. This 2 will cancel it 2 times. This will be cancelled 5 times. Again, you can cancel this 5 times. So this 5 and 5 will cancel this 25. So that means the volume of one matchbox will be equal to 15 centimeter cube. Now you have one packet and that packet is containing how many such matchboxes? That packet contains 12 such matchboxes. So if you want to find out the volume of the packet, so volume of the packet will be what? Therefore, volume of packet, that will be equals to what? That will be equals to 12 multiplied by volume of one matchbox, right? Volume of one matchbox. Okay. So what will you get? You will be getting 12 multiplied by 15. Okay. 12 multiplied by 15 will be what? That will be 180 centimeter cube. So that will be the volume of the packet which they are talking about here. Like what we did here, we know that when we are talking about matchbox, the matchbox is actually cuboidal in shape. We know the formula for the volume of cuboid, that's L into B into H. So we can easily calculate the volume of one matchbox. And since the packet that we are talking about here, it contains 12 matchbox. So if you want to find out the volume of the packet, you have to calculate volume of one matchbox multiplied by 12 and you will get your answer. Therefore, the answer is going to be 180 centimeter cube. I hope it is clear to everyone. Done? All right. You can see the solution here as well. We are given the dimension of the matchbox. These are the dimension. So length is 4 centimeter, breadth is 2.5, height is 1.5, and the matchbox is cuboidal in shape. So the value will be L into B into H. So if we calculate the volume of one matchbox, that will be 15 centimeter cube, and volume of the packet which contains 12 such matchbox will be 12 into volume of one matchbox. So you will be getting 12 into 15, and 12 into 15 is nothing, but that is equal to 180 centimeter cube. Therefore 180 centimeter cube will be the volume of the packet that we are talking about here. Clear? Done? All right. So now we have the difference between volume and capacity. So this table will be very helpful. So we are going to learn what is the relation or the difference between volume and capacity. So when we talk about volume, volume indicate the total amount of space which is covered by an object in three-dimensional space. All right. You take any, let's say I have this pen. All right. I have this pen. So the total amount of space which will be actually covered or occupied by this pen in this three-dimensional space in which I am will be referred to as volume. Clear? Now, when you say capacity, capacity refers to the ability of something like a solid, substance, gas, or liquid to hold, absorb, or receive by an object. Capacity means how much that particular thing can hold in it. Okay. Capacity means what is the ability or how much ability or what is the maximum value which a particular object which we are talking about can hold, absorb, or receive. That's what we call as capacity. There is a minor difference although. Okay. When you are talking about volume, volume is generally measured in units like centimeter cube, meter cube. Okay. And when you are talking about capacity, it is meter generally in liter, gallons, pounds, etc. Okay. Now, when you are talking about volume, this point is very important point. When you are talking about volume, then both solid and hollow object have volume. Okay. Like it does not matter actually whether the object which we are talking about, that's a hollow object or that's a solid object, that do not have any meaning here. Both the solid and hollow object can have volume. But if you are talking about capacity, then only hollow object can have capacity. So this third point is an important point, I would say. Okay. This third point is very important. When you are talking about volume, that means both hollow and solid object can be considered. On the other hand, if you're talking about capacity, only hollow object can be considered. So the examples we have, cube is there, cuboid is there, cone is there, cylinder is there. Okay. Similarly, when you are talking about capacity, cone, cylinder, hollow, hemisphere, there are multiple examples actually. Clear? So the third point is very important, I would say, when it comes to relating or the difference or the similarity, I would say, between volume and capacity, relation between them. Clear? So make sure that you go through each and every point thoroughly after this section. Is it done? Okay. So now what do we have? We have one problem. What does it say? You have to find volume and capacity, in liters of a cylinder whose radius is 7 centimeter and height is 20 centimeter. So when you are talking about cylinder, in case of cylinder, the volume and capacity is going to be the same thing. That's a very important point to note. Okay. And we all know what is the formula for the volume of cylinder. Okay. So here we are provided radius. What's the value of radius? Here the radius that we have, radius r, that's equal to 7 centimeter. Okay. We are also provided height. What's the value of height you have? Height h, that's equal to 20 centimeter. Understood? And we know the volume. What is volume? Volume is given by pi r square h. Clear? So what is pi? Pi is 22 by 7. What is r square? R square will be 7 into 7. H is 20. So 7 will cancel it. So what will you get? You will get 2 into 22. That will be 440 into 7. If you multiply it further, you will get 7 into 0 is 7. 7 into 4 is 28. And 7 into 4 is 28 plus 2, that is 30. So you are going to get 3080 centimeter cube. That is the volume. But this is the volume actually. Now, if you're talking about capacity, the only difference would be numerically the value would be same in both the cases. The only difference will be in the case of unit. Let us cross check the calculation before we actually move to the result. So you have pi 22 by 7, r is 7 into 7, h is 20, cancel out. You will have 440 into 7, 700, 28, 7 to 28, 30. Okay, perfect. So this is the volume that you have. Okay, volume that you have. Now we are talking about capacity. So when you are talking about capacity, that means they are asking you the same value, but they are asking you that value in terms of liter. So if you talk about capacity here, then capacity will be what? You will have 3080. Like, what is the relation between centimeter cube and liter? Like, that's very important to know actually. That's very important to know actually what is the relation between centimeter cube and liter. So I am telling you here 1000 centimeter cube is equal to 1 liter. Clear? So if you have to convert it into liter, you have to divide it by 1000. Clear? So what will you get? You will get 3.08 liter. That is the capacity. So numerically, both the values are same here. It's just the unit which is going to make difference. Understood? Done? All right. So you can check here, radius was given, height was given, they calculated volume which is equal to 3080, and the formula they used is pi r square h. This is pi r square h. Okay. If they talk about capacity, we know that 1000 centimeter cube is equal to 1 liter. So the capacity is 3.08 liter. This is important here. The important point is we can also represent capacity in terms of centimeter cube. So like there is no difference. That's what I told you. Like the value is same. It's just the unit that is making difference here, nothing else. Is it done? Okay. So now you have these two questions that you have to try as a homework, guys. So these two questions you guys have to try as a homework. In case you do not get the answer to these problems, like the answers are given here. In case you do not get these answers, you can always get in touch with your Ask Guidance expert and get it rectified or clear. So before we end this session, it's very important to revisit the topics that we covered in today's session. The very first topic that we covered is surface area. We understood what is the meaning of surface area. Then we discussed the surface area in case of cube, in case of cuboid, and in case of cylinder. Three cases. All right. After that, we discussed the meaning of volume. We discussed volume in case of cube, in case of cuboid, and in case of cylinder. In the third topic, we discussed what is the relation between volume and this capacity. All right. And thereafter, we did few problems based on all the topics that we covered in today's session. And I hope all those problems which we discussed in today's session, they are very, very clear to you. And these two questions that you are provided here, you have to try as a homework. In case you do not get the answer to these problems, you can always get in touch with your expert, and here you can see the answers. These are the answers that are provided to this problem. So please try it, and in case of any problem, get in touch with your experts. So that is it from this session. Thank you so much. for attending this session. Stay safe, enjoy. I'll see you all in the very next session. Till then, goodbye.